So last class earlier mugitu. So where was in the last class? So operators we have started, right? So Python operator. So we were just checking about the this double star operation because we have not seen this in the any other programming language because this is the exponential one. So we'll check that code. Okay, for exponential we were just checking. So what is the first value a, and if you use the b, it double the power b means a to the power b means 3 into it will be 5 times. So 5 times it will be gets multiplied. So for that we were doing the exponential one. So in this programming language, if you want to do like that exponential, so we just have to use the 2 stars. So then let's, if I execute the code, I am getting 243. So if we multiply 3 into 5 times also, we get the 325. So we are getting the 240. Okay. So this is just a 5 times value. So we can do like this. For example, if it is 100, so can we do like this? So 100 times we have to type this 3 into 3 into 3 into 3 into 3. Like that 100 times we have to type. Otherwise, we have to build a logic. If you use it in a C programming or any Java programming or C# programming, so you have to create a one for loop which will iterate 100 times in a loop which will repeat 100 times. So in each time you will multiply 3 into 3 and you will store to some value, and in each iteration it will be keep multiplying with the 3. Okay. So but in Python how much simple it is means, so we just do the 2 stars and the second value is the power. So for example 100. So if we execute that code, so we get the value. So it multiplied 100 times. So like this, so Python is, we call it as a very simple programming language. So because we are having a lot of features like this in the Python programming. So this is the floor division. This is also will check so how it will work. So this operator will divide the first argument by the second and round the result down the nearest whole number, making it equivalent to the math.floor function. So what it will do, so it will divide the first value by second value, and it will, if there is any fraction value, so it will make the nearest equivalent whole number. So for example 4 they are doing, so 4 3 is a 3 point something will come, so then it is making as a 3 whole number. So we'll try with our IDE. So just by the double slash, for example is that 30 with 4. So then B. And I just execute the code. So I got the complete whole number. But if you divide the 4, just do single division. So we are getting a 7.5. Okay, but if we do the double slash, it will give the nearest whole number 7. So let's give it 32, 8. For this also it's giving 30. So we'll debug and we'll see. So internally what's happening, we can see step by step. So A is the integer value, B is the integer value. So then we are doing the floor. So when it happens, so the C value will be stored as a floor. So usually in other programming language, we were using the math operation to floor to make it a equivalent nearest to whole number. So but in the Python programming, we just use the one more slash to make it a whole number. Okay, these are all the mathematical operators. So mathematical operators like addition, subtraction, multiplication, division. Along with that, so this is the two features we are having in the Python. So that is the exponential and this is the floor. So now let's go to the next operator. So and there is a Python assignment operator. So the Python assignment operator is the single equal. Okay. So first we'll go to the single equal operator. So we are already using the single equal operator from the beginning output. Okay. So this is the what is the use of the single equal operator? Narmada.
Yes, sir.
What is the use of this single equal operator?
A value is 31.
Huh?
B is.
Now, what is the use of this single equal operator?
Equal operators means A equal to A value 31.
Yeah, so it means that right side value will be assigned to the left side variable. So this is the single equal operator. That is that we call it as a assignment operator, single equal. We also use the double equal and triple equal. So double equal, it will give the result. A double equals to 31 means, so for the condition time, so we will use. So for example, if we are using in the if condition, we check the condition A is double equals to 3. So that time it will compare the right and left side value when we use the double equal. So but when we use the single equal, so whatever the value is there in the right side, so that value will be assigned to the left side variable. Okay. So this is the single equal operator. So from the beginning we have used this. So to assign the values. For example, if I want to assign the any value for the any variable, so first we declare the variable and we use the single equal operator. So then we will put the value. So there is a single equal operator. So along with that same like that, so we have a plus equal, minus equal, into equal. So we'll do one by one. So you can mute Narmada. Okay, so what happens when we do the plus equal? So this is the plus equal. So plus equal means, so that will make the addition with this b only, b with a, and the value will be the total b plus a value will be stored in the b variable. Okay, but usually what we were doing, c equals to b plus a or a plus b. Okay, if we do like this, what will happen? So both the values, whatever is there in the a and b, so it will do the addition and it will store the value in the c variable. Okay, so but What is the use of this plus equal means? So for the same variable b, we are going to add this 31 to 4. So then a value will be 31 plus 4. So then we are not using a one more third variable c. So for the same b variable, we are just going to make the addition with the 31. So that time we will use the plus equal and then variable a. So then we'll debug and we'll see so how it works. So first a is declared with the integer type, b is declared and the value assigned as an integer type. And when that b plus or equals to a happens, so b value is changed to 35. So before it was 4. So then when it has been added, so when we use the plus equal, so then it is added the 31 to the b and the b value will be assigned as a 35. So now if we print that, so the b value is 35. So this is the plus operator. So in the same way we can test the minus operator, minus equal. So minus equal, it will do the b minus a, and resultant value will be stored in the b variable. So the resultant is the minus 27. So we can do with the multiplication also. So multiplication also will happen the same thing. So b into a will happen and the final value will be stored in the b. So b value is 124. So these are the assignment operator along with the addition, subtraction, multiplication, and division also is there. And this is the modulus, and this is as usual division and float, and this is the exponential. And this is the logical and this is the logical OR operator. So we'll check the logical and logical OR. As I think these are the things we have already tested. So we'll check the logical and logical OR operator. So logical and for this equal is so the value is 4. So how we get the 4? Anybody know? Arut, do you know? Have you used this logical and?
No, I never used that one.
Okay. So usually, I think everybody, if they are from computer science or electronics background, so they will know the logical operations like AND gate, OR gate, XOR gate, like that. So in the same way, there is a
And
logical, yeah. So there
if
is
any
a,
one true,
yes, yes,
if any one true, the result will be true.
yes. So this is the one actually. So anyone, so if both the values are true, so then the result will be true. If any one of the value is false, means any one of the value is 0, so the result will be 0, right?
Yes.
And or operation. Okay, so when we are doing the logical AND operation, so what will happen with this value means for 31 will be converted to binary value. Okay, what is the binary value for the 31? So let's convert from decimal to binary. So for the 31. So this is the binary number. Okay. So then what is the binary value for 4? So it is the 10. So if you do the addition with all ones and with 1000, so we get some binary value. Okay, so that total value will be convert again to from binary to decimal. So then we get the result value 4. So like that, logical AND operation will happen. So when the logical AND operation will happen, like, so what is the value of that decimal value 31, integer 31? So that will convert that 31 to binary value and this 4 to binary value, and they will do the logical AND operation. So as you told, so high and high value, so this will apply. So this formula will be applied. So 000 100 100. So either when only it will be high means it will be 1, only when A and B value will be 1. So when both the values are high, so the output will be high. So even in the machines, all the computers will work under this zeros and ones, right? So any program which we are developing, so these are all the English human understandable programming language. So that's why we call it as a high level programming language. So when we use the interpreter or compiler, so it will convert that code to machine executable code. So machine executable code means it is zeros and ones. So our final end output will be zeros and ones. Each instruction set will be in the, for example, if you take this instruction set, so this instruction set will be completely in the zeros and ones. And whatever the computer processor we are having in our laptops or the system, for example, if it is an Intel, so there is a, even you will be seeing that in the configuration while taking the system or taking the buying the system, so you will be see the 32-bit processor, 64-bit processor, like that means, so it executes the instruction set, 32-bit instruction set in one cycle. Okay, in the same way, so whatever the programs we give to the processor, it will execute and it will give. So in the same way, so this is one, we do the operations like a arithmetic operations, like a addition, subtraction, multiplication, all those things. In the same way, in the programming language, we can do the logical AND operation. While doing the logical AND operation, so it converts that decimal to binary, both A and B. So then it will apply the logical AND operation as per the logic. Okay, so OR will be the reverse for this. So only when low, both the values are low, then only it will be low. Sorry, see the logical OR also. Okay. So only when both the values are 0, the output value will be 0. Okay, if there is any one value will be high, so then the output value will be 1 high. So this is the logical OR operation. So while doing that in the programming, if we require, so we can use this pipeline operator as an OR operator, and we will get the result. So we get the value 31. Okay, if you guys interested to do that, you can convert that binary value and you can check that final result. Final what is the binary value, and you convert that again binary value to decimal, so you will get this same. And this is the logical XOR. So whatever the OR will happen, so it will reverse that value. Means if it is a 0, it will make it as a 1. If it is a 1, it will make it as a 0. Whatever we find at the last, so it will do like that. So let's do that and we'll check what is the output. So we get the 27. So if you want to try it practically, by manually checking, so you just convert this A value into binary and B value into binary and do the OR operation, and you just invert that binary final value, and you just convert that binary value to decimal, so you will get the 27 value. So in the same way, there is a right shift and left shift. Okay, so this is also binary operations. So binary operations means, so the right shift means, so whatever the right side value will be there. For example, if there is a 3, so then the value will be shift 3 times to the right side. For example, we converted for example 42 I will give. Okay, so this is the binary value. So if we do the shift 2 times, so this 20 will be added here. So if there is a 2 shift will happen, so this 10 will be shifted, and at the initially it will get the 20. So this 2 shift, this 2 value will be go. So then the final value will be this thing after shifting the 2 bits. So like that, if there is a 3, so it will shift that value 3 times. So that is the binary shift operation. Okay, we can do that binary shift operation with the 2 greater than symbol to the right side. So A value is the 31. So B, for example, 4. If you shift that 4 value, for example, it would be 0101. So that one, if you shift 31 times, so obviously we get the 0 only. So I will do one thing. So I will A value I will do as a just 2 times shifting with the 23. So I get the value 5. So if you shift and if you convert that final value to the binary, so we get the 5. So in the same way we do the right shift. If we do to the left side, so it will shift the value to left side. So for example, we shifted the value to right side. So in the same way, the value will be shift in the left side, and the value will 0 zeros will be added at the end, right side end. So then whatever the final value we get, if we convert that, that is the right shifted value. So this is the right shifted value. So the left shifted value and right shifted value. Okay, this is the actually binary operations. Whatever we have seen from AND operation to shifting the bits, so that is the operation. Okay, so then there is a Python comparisional operator. So comparison means, so as we seen for the double equal, so single equal will be used to assign the value. So in the same way, when we use the double equal, so it will check the right side and left side value. Okay, so it will compare the right side and left side values. If it is both are equal, then the result will be true. Otherwise, it will be the false. So let's check that A is double equals to B. Okay, so here it will not assign any value, it will just compare the value A and B. So the resultant is false because A and B value are not the same. So that's why it is printed false. So if we make both the values are same, for example, A equals 23, B equals 23. Then if we execute, we get the false. Why? Okay, so we are shifting it. So that's why in the third step, the value is changed. So then we got the output as a true. So when there is a both the values are same, so if we use the double equal, so it will check the condition. It will not assign the value. So when we are assigning the value means, so we will use only single equal. So then what is the not equal? So there is one more operation, that is a not equal. So if A is not equal to B, it means that if A is not equal to B, then only it will print true. Otherwise it will print false. So now it will print true or false. Can you tell someone? Now it will print true or false when we use not equal. Means this is the condition, not equal. So A and B are the value. So you know A value and B value. So when we make not equal, what will happen? So if it is only not equal, if A and B value are not equal, then only it will print true. Means if both values are equal, then it will print false. So then I should get false because both the values are equal. It's not a not equal. Okay, now I will change the value from 23 to 20. So it means that it is not equal. So then A condition is not equal should be true. So we got the output true. So and then we'll check the greater than. So this is also a conditional operator. So means it will check the right side and left side value whether it is a greater or a less. So for example, I will check the greater. A is greater than B. If A is greater than B, if it is true, it will print true, otherwise it will print false. It is printing true because A is greater than B. So we'll check the less than and greater than equal and less than equal. So A is less than B. No, A is greater actually. So it will print false. So then we'll check the A is less than or equal to B. So it will print false because A is not or equal to, means it is not a less than, also it is not a equal. So if we make the equal value also, it will print true because in both the condition it should match anyone. A and B value should be equal, otherwise it should be less than.